This video is a video about trapezoids, trapelapazoids. In particular, we're going to talk about really isosceles trapezoid for the most part. Okay. First and foremost, a trapezoid by definition is a quadrilateral that has one pair of opposing parallel sides. So it could look like that. So we have one pair of opposing parallel sides. Okay, if we had two pairs, then it would be a parallelogram. But the trapezoids only have one pair of opposing parallel sides. They could look like that, or they could even look like this, standing up. There's my one pair of parallel sides. Um, these trapezoids, in and of themselves, of course, you have parallel lines, so you can get some congruent angles out of the deal, or supplementary angles. But they're not altogether that interesting, so we're going to focus on a certain type of trapezoid, and that's going to be the isosceles trapezoid. And just like an isosceles triangle, isosceles trapezoids have two congruent legs. So an isosceles trapezoid looks like this. We have the trapezoid part, which means parallel sides. So we have one pair of parallel sides, and that's the trapezoid part. But we also have congruent, what are called legs. So the non-parallel sides are congruent. And that would be these guys right here. Okay? And so most of our attention will be paid to isosceles trapezoids. And the isosceles piece means that those two legs, the non-parallel sides, here are two parallel sides, will be congruent, much like an isosceles triangle would have two congruent legs. So many of the properties occur in an isosceles trapezoid and not a regular old non-isosceles or regular trapezoid. So we're going to focus our attention on isosceles trapezoids. So if that is indeed the definition of an isosceles trapezoid, so here's our definition, right above here. So it's a trapezoid with a pair of congruent legs, basically. From that, we can establish some properties. So here are our properties. So we'll call them properties of an isosceles trapezoid. And the first properties have to do with the angles. And so this is kind of a clever little way to think about the angle. So I'm going to start with an isosceles trapezoid here. And here are my parallel sides, which makes it a trapezoid. And here are my congruent legs, which makes it an isosceles trapezoid. And what I'm going to do is I'm going to cut that up, and I'm going to cut it up into basically an inner rectangle. I'm going to drop two altitudes. And this guy ends up being a rectangle. Okay? And because each of these altitudes, these blue segments, represent the distance between the two parallel lines, they're going to be congruent as well. Because the distance between two parallel lines doesn't change. That's why they're parallel. And of course, it's distance because of the perpendicular piece. And so basically what I can show is that both these two triangles are congruent by HL. They're right angles. I got congruent legs, which are the both altitudes, and I have congruent hypotenuse because of the definition of isosceles trapezoid. And so since those two triangles are congruent, I can get some corresponding parts to be congruent, namely these angles right here. Okay, those would be congruent by CP/CTC. And so that's my first property. Oops, I don't have to write property again. And those lower base angles are congruent. Those are the black angles here. The lower base angles are congruent. Again, and that spills out of CP/CTC, the two triangles which I created from the original isosceles trapezoid. Okay. Also by CP/CTC we get these two angles up here to be congruent, and when added to the same 90s, what that ends up is meaning the whole upper angles are also congruent by the addition property of equality. So the upper base angles are also congruent. Okay, and of course the whole upper base angles, if I erase some of this stuff in here, would be this whole angle and that whole angle. And I'll draw those for you in a second. Okay, so basically because of those two congruent triangles, I can establish that this will happen. Okay, and I'll draw a nice picture that will depict both of those situations. Let me get rid of this for now. And so when we have, oops, nope, an isosceles trapezoid, which by definition means one parallel pair of sides and the other side's congruent, then these angles will be congruent. These are the lower base angles, and these angles will be also congruent, upper base angles. Okay. Of course, since we have parallel lines, these consecutive angles will be supplementary. Those will be same side interior angles. So that would be a third property. Parallel lines, these two blue and black angles, same side interior angles. We got two parallel lines, therefore they're supplements. So that's a third property. So consecutive angles are supplements. Oops. Okay, and just as before, therefore by the substitution property, so are opposing angles. They're also supplementary. Blue and blacks are subs. Blue and blues are the same, and blacks are the same. Okay. So for example, if this angle were, let's just say this lower base angle were 80, then this angle has to be 80 as well, because lower base angles are congruent, and this has to be 100 because consecutive angles are supplementary, and so does this have to be 100 because these two consecutive angles are supplements. Okay, opposite angles supplements too. All right, so those are properties that have to do with the angles. There happens to be one more property of an isosceles trapezoid, and only an isosceles trapezoid, that has to do with diagonals. And here's my isosceles trapezoid. Okay, and if I create the two diagonals, here's one, and I'll make the other one in black. Here's two. What you'll find is that those diagonals are congruent. And the reason they're congruent is, again, because of corresponding parts of congruent triangles. And these would be my congruent triangles. That triangle and this triangle here. Okay? And so therefore the diagonals would be congruent. Well, maybe you don't buy that congruent diagonal argument, so here's another example. I'm going to start off with a specific isosceles trapezoid, and let's put these points here, here, and here. And the way that I make isosceles trapezoids, you kind of start out with a rectangle and add two congruent right angles on the left and right of that. So that allows me to create these trapezoids, which are isosceles, which if you kind of drop this here and here, again, here's our little rectangle in here, and here are two congruent right triangles. Okay. But again, what we're trying to show here is that the diagonals are congruent. So I can use the distance formula for this particular diagonal, and the distance is going to be the square root of the difference in the x's squared. So that's 7 minus 0 squared plus the difference in the y squared, 4 minus 0 squared. Again, 0, 0 is a nice point to use. So that ends up being the square root of 7 squared plus 4 squared, and that's not 11. Okay, you can't pull the 7 and the 4 out. That's going to be root 49 plus 16, which is going to be root. When I add those two together, I get 5 and a 6. And root 65 has no square factors, so I can't simplify that any further. Okay, now I'm going to find this other diagonal. And again, I'm going to use the distance formula. And so I'm going to take the square root of the difference in the x's squared, so that's 10 minus 3. The order doesn't matter because I'm going to square it anyway. Plus the difference in the y squared, 4 minus 0. And that ends up being 7 squared, 10 minus 3, 7, plus 4 squared, which is 7 squared, 49, 4 squared, 16. Oh, I got the same thing. Okay. So for this particular problem, the diagonals are congruent. And in fact, what you'll find is that for all isosceles trapezoids, the diagonals will be congruent. Okay. So here, to summarize, is the definition of an isosceles trapezoid. It's a trapezoid, which by definition has parallel sides, one pair. Okay, and the isosceles piece comes into play because these non-parallel sides are congruent, much like an isosceles triangle has two congruent sides. And here are all the properties. Okay, we have lots of angle properties. the lower and the upper base angles are congruent. And if the angles aren't congruent, then they have to be supplements, or any other choosing of two angles will give us supplements. And we also have the congruent diagonals as our final property. Thanks for listening to the isosceles trapezoid presentation. See ya.